Well, folks, this is Mr. Bergman again, and today I want to talk about something called molarity. Last time we learned about saturated and unsaturated solutions, but scientists are not happy with just saturated versus unsaturated. They want to measure the unsaturated solutions. If it's saturated, we can measure that, but if I have something that's got a certain amount in it versus another amount in it, but they're still unsaturated, we want to measure the unsaturatedness of something. So that's what we're going to learn about today, is the unsaturatedness. We measure it using something called concentration with the unit of molarity. Everybody say molarity. Molarity. So let's have at it right now. All right, so molarity. What is molarity? All right, let me get my pen set up right here. All right, molarity. Molarity. Now, if you think about the word molarity, it has the word mole built into it, doesn't it? All right, so molarity is a measure of something called concentration. You've probably had an experience with concentrated orange juice versus unconcentrated orange juice, if you're mixing it up. So there is concentrated. But the concentration is, by definition, the amount of solute dissolved in a given amount of, these typos everywhere, of solvent. Typo there. Okay, so you want to copy that correctly. All right. Now there are dilute solutions, where you have a low concentration of a solution, and you have a concentrated solution, where you have a high concentration of a solution. And this is a relative term, depending on which particular chemical you have, whether it's concentrated or whether it's dilute. So for example, if I have a picture here, here's a dilute solution. The dissolved particle looks like it's a pinkish color. So this is dilute, less dilute, kind of concentrated, more concentrated, and like really concentrated. So if it happens to be a colored solution, you can tell the difference. You know, you might know this. For example, like we talked about Gatorade a couple of podcasts ago. Gatorade has salt in it, but you don't really taste the saltiness of it. But I don't know if you've ever been to like the ocean and you taste it. You can taste the salt there. So there's concentrated salt water and there's just kind of concentrated salt. You know, there's dilute salt water. Okay? So now, molarity is actually a mathematical expression. Molarity is the moles of solute divided by the liters of solution. So if I have a solution that has, we would say, 1 molar, and the symbol for molarity is M, then you would take 1 mole of something and you would dissolve it into 1 liter of solution. So you'd have 1 liter here, and you took 1 mole of some, whatever substance, and you dissolve it. You could determine the substance's molarity. All right. Let's actually let's do this example, and then I'll do one for real for you. So what is the molarity when 2.3 grams of sodium chloride dissolved in 250 milliliters of water? This is actually very simple. The units, of course, for molarity is moles over liters. So what you do is you say there is 2.3 grams in 250 milliliters of water. Now I've got the right substances. I got grams on the top and milliliters, but I want moles per liter. So then I've got the grams. So I want to go from grams to moles. Now this is sodium chloride, so then I look up on my periodic table, find the weight of sodium, which is 23, and the weight of chloride, which is 35.5 from the periodic table, and that would be 58.5 grams in 1 mole. The grams cancel, and now I have moles per milliliter, but the definition of molarity is moles per liter, so I keep on going, and then I say, well, I've got the milliliters, it's on the bottom of the fraction, so I'm going to put it on the top of the next fraction. And there's milliliters to liters. And if you recall, 1 liter is 1,000 milliliters. The milliliters cross, even though it's kind of a long distance, and now let me get my calculator out. So my calculator, I'll take a 2.3 divided by 58.5 times 1,000 gives me way too big a number. That doesn't make no sense to me. 2.3 grams dissolved in... what did I forget? Mr. Bergman, you're an idiot. Okay, so I got 39. That's way too big. Let me do that again. You would take 2.3 divided by 250. That's what I forgot to do. Divided by 58.5 times 1,000. And you get 0.16 molar. 0.16, and we use the symbol capital M for molarity. And so we say 1.16 molar. Okay? Okay, so now over here what I have is I have my scale. And on this scale I have a weigh boat. And I'm going to take a particular amount of nickel nitrate. Get this, you can see this. Nickel nitrate. I'm going to place it into the pan. So you can see I'm going to get the nickel nitrate right here. I'll just get a certain amount, and you can see the scale. We'll zoom in on that. And here is a particular mass of the nickel nitrate. So how much nickel nitrate did I get? You can see I have 0.33 grams of the nickel nitrate right there. And the nickel nitrate is this sort of green powder that you see right here. All right. Now what I want to do is I want to take the nickel nitrate and I want to dissolve it, and I want to be really accurate about this. So I'm going to use a new device that you may not have seen before. This is called, it's probably zoomed in too far. This is called, sorry, probably messing your brains. This is called a volumetric flask. Everybody say volumetric flask. Now if you look at the volumetric flask carefully, you'll see that this one says it has a 200 milliliter volumetric flask. And the thing that's interesting about this 200 milliliter volumetric flask is there's only one line on the flask. And if you can see that line, the line is right here. It's kind of hard to see probably, but that's the line that we're going to fill this to. So what I'm going to do now is I'm going to fill the volumetric flask with the powder. So now I'm over here in my screen. I'm going to take the nickel nitrate and I'm going to add it into my flask. Alright, sorry, I forgot a particular piece of equipment, so I had to kind of go there to cook it. Now, notice here I have my my green powder, and there's a little water in here. That's not a big deal to add a little water in your volumetric flask. So I'm going to carefully pour this into here. But I have a problem. Notice that I still have some green stuff in here. And so what I'm going to do is, so you can see it, what I'm going to do is I have a squirt bottle right here, is I'm going to take this and I'm going to actually wash the water. Let me see. There, that's better. I'm going to wash the water, or the powder, into the beaker just very carefully so I get every last grain of the green stuff, the nickel nitrate, the nickel 2 nitrate. Now notice that this is completely clean, and in my solution now I have a green solution. So, but if I want to make it an exact concentration, which we're going to do, I will then essentially just fill this up with water, and you can see I'm squirting water into the volumetric flask. Usually what I like to do actually is to take the lid off, and as I take the lid off I then pour it in. Now I don't fill it all the way to the top yet. What I've done is I've filled it up about to this spot, and then I can kind of shake it. And so as I shake it, it's dissolving. The green powder now is all gone. This is now a solution, but I really want to get it to my line. My line is right here. So what do I do then? Well, at that point, I then put my lid back on top of my water squirter, and then I want to go slowly, and you can't really see. There we go. So I'm going to do this, and I'm trying to get this so that it's exactly on the line. I'm getting it there. I must not have a good seal here. Hold on. There we go. Now much better. And notice it's getting closer on the line. Now as you get kind of in the neck, what I've found that to be really effective is that if you take this and the line, if you can see, is right here where the finger is. So I've got to go from here to here. What students generally find the easiest, I'll just go ahead and do this just for the sake of the video. I want to stop where the bottom of the meniscus, oh I'm good, the bottom of the meniscus is right on that line. But a lot of students find that it's useful to have one of these barrel pipettes to sort of finish it off. And so I would recommend you might want to think about that. But now notice that I have a solution, and now we're going to calculate what the molarity of this particular solution is. So what I had nickel 2 nitrate. I had 0.33 grams of nickel 2 nitrate. Now nickel 2, the 2 means plus 2, and nitrate is NO3 minus 1, so it's NiNO3 2. And I put it in exactly 200 milliliters of water. Actually, what I did is I filled it up to 200 milliliters, so it's a slight difference because the nickel nitrate takes up a little bit of space. So if I were to do the math, 0.33 grams in 200 milliliters. So the math of this one is just like that last one we did. Then I'll say grams per mole. Now this will be for the nickel 2 nitrate. Now the molar mass of nickel 2 nitrate is 183 grams in 1 mole. And so my grams cancel. And if I want to get the milliliters to cancel, I will say 1,000 milliliters is 1 liter. Sorry, I bet the voice was a little softer there, my fault. So now I just do the math. So it's 0.33 divided by 200 divided by 183 times 1,000. And I get that solution. Hold on, pen. I lost my pen. All right, that solution was 0.092, and we use a capital M for that. Okay? Not terribly difficult. All right. What about another example? How many moles? All right, this is not asking for what's the molarity, but how many moles are in a solution. Now this brings up actually a very important equation I want you to write down. That is this equation. M times V equals moles, where M is the molarity. So when I see this, I have a 0.35 molar solution. Watch how I write this. I'll write 0.35. Now I do not write capital M. I will write moles per 1 liter. And I'm going to times that by the number of volume, which was 125 milliliters. Now I'm going to kind of do a quick calculations in my head. If I take 125 milliliters, I'll do it on the screen, 125 milliliters, and I can say there's 1,000 milliliters in 1 liter, that's 0.125 liters. So if I then times that by 0.125 liters over 1, the liters cancel, and so you just take 0.35 times 0.125, and you get a number of moles of 0.044 moles. So it's just, multiply MV. The key thing is you've got to make sure your volume is in liters. Very commonly it's given in milliliters. All right. So that's essentially today's podcast. Have a great day. Bye.